Okay, so I do the first derivative of y. I would get an is a constant. So you do derivative, you would get n times x to the power n minus 1, right? Because you do derivative of y to x. So you would get a n times n x to the power n minus 1. When you do the second derivative, you would get n times n minus 1 x to the power n minus 2, right? And then you just plug the second derivative of y into your differential equation and put y is equal to an x to the power n into your differential equation. Now, you are going to combine these two terms together. But the thing is that this x is to the power n minus 2. But this x is to the power n. You cannot plus them together. You're going to plus them whenever you have the same power of x, right? So in that case, I say that, why don't we put the number of n until we find, how to say, the values of x to the power n, which is the same as these two power would be the same. Okay, so the thing that I do is just that I put the value of n equal to 0 to see what would be the value of this term. I know that if I put n is equal to 0, I would get 0. If I put n is equal to 1, I would get this term equal to 0 too, right? And now my summation would start from 2 to infinity, right? Because n is equal to 0, I got 0. n is equal to 1, I got 0. But n is equal to 2, I don't get 0. So now my summation starting from 2 to infinity. And next, what I'm going to do is called shift of index of summation. This one we call the index of summation. I'm going to shift it in such a way that I'm going to put it in such a way that I would get x to the power n for this term. So if I want to get x to the power n of this term, what should I do? I should put n is equal to n plus 2, right? If I put this n is equal to n plus 2, then this x would be x to the power n, right? Okay, now if I want to put n is equal to n plus 2, the whole term here got to change. The whole term which has n got to be changed to n plus 2. Okay. Then the next step, what I do is just any terms in here, I put it as the n plus 2 to do the shift of the index of summation. Now this one become n plus 2 equal to 2. Now my an would be equal to an plus 2. And this n would be equal to n plus 2. This n is equal to n plus 2. And n for the x is equal to n plus 2. By doing that, I would get n plus 2 equal to 2. So n is equal to 0. See, I already do shift of this index. And this one starting from n plus 2. This one you would get n plus 2. This one would get n plus 1. And now we get x to the power n. To do the shift of index, it's making us to combine two terms together. Okay. Now, these two, we would be able to sum them together, right? Because now you have n starting from 0 to infinity the same, and you have x to the power n the same. So in that case, you do summation of them. by doing that, because this one, an plus 2 times n plus 2 times n plus 1, they all are the constant. And this an is a constant too. So when you do sum them together, you just sum, because the last term you have x to the power n percent. So to do this, you just put the constant to do summation of them. So you would get an plus 2 times n plus 2 times n plus 1 minus an, and the whole term times x to the power n equals to 0. Now, in order to make this sentence, in order to find the condition which is satisfied to this sentence, this sentence would be correct if x to the power n equal to 0 or the term in the parenthesis is equal to 0. But if you set that x to the power n equal to 0, that doesn't make sense, right? That doesn't make sense. So that means your y is equal to 0. You would get the answer that y equal to 0. Y equal to 0 is a trivial solution. So that wouldn't be happen. So we have only one way out to make this sentence satisfy, which is the term inside the parentheses equal to 0. When you set the term inside the parentheses equal to 0, and then you would get an plus 2 equal to an divided by n plus 2 times n plus 1. And from that, if you want to know the rhythm of an plus 2, you would say that assume n is equal to 0, you would get a2. You would get the value of a2. a2 would be equal to a0 divided by 2. If you plug n equal to 1, you would get a3. a3 equal to a1, right? Right? Because you put n is equal to 1, right? You would get a1 divided by 3 times 2. 3 times 2 is equal to 3 factorial, right? Then you plug n equal to 2 there, you would get a4. a4 is equal to a2, right? Because n is equal to 2. a2 divided by 4 times 3. But your a2 is equal to a0 divided by 2. So you just put the value of a2 there, you would get a0 divided by 4 times 3 times 2, which is equal to 4 factorial. Then we put n is equal to 3. Now we got the rhythm of it. So now that term, you would say that a0 divided by 2, it seems like a0 divided by 2 times 1, which is equal to 2 factorial. When you plug n is equal to 3 there, you would get a5. a5 is equal to a3 divided by 5 times 4. a3 itself is equal to a1 times 3 factorial. You plug the value of a3 there, you would get a1 divided by a factorial. You would get a1 divided by 5 times 4 times 3 factorial, which is equal to 5 factorial. So you would get a1 divided by 5 factorial, and so on. Now you see the rhythm is just go on by a2, a4, a6, a8 would be the function of a0. And a3, a5, a7 would be the function of a1. Now, we go back to our y. Because we assume that y is equal to summation of an x to the power n by starting from n equal to 0 to infinity. If you write this term, you would get a0 times x to the power 0 plus a1 times x plus a2 times x to the power 2 plus a3 times x to the power 3 plus a4 times x to the power 4, and so on. Now you plug the number of a that you find, you would get a0 plus a1x. But your a2 is equal to a0 divided by 2 factorial. And your A3 is equal to A1 divided by 3 factorial. And your A4 is equal to A0 divided by 4 factorial. Your A5 is equal to A1 divided by 5 factorial. And your A6 is equal to A0 divided by 6 factorial. Do you see the rhythm there? Okay. Now, you rearrange it again. A0, you put them together. You would get 1 plus 1 over 2 factorial x to the power 2, x to the power 4, x to the power 6. So the next term would be x to the power 8, right? And the number in front of it would be 1 over 1 factorial, 1 over 2 factorial, 1 over 4 factorial, 1 over 6 factorial. The next one would be 1 over 8 factorial, and so on. Now, for the terms of A1, you take A1 out, okay, you would get x plus 1 over 3 factorial x to the power 3 plus 1 over 5 factorial x to the power 5. The next term, what would you get? Guess. I let you guess. The next term would be 1 over, the next term of this would be 1 over 7 factorial times x to the power 7. Now you know the rhythm of that, right? So I rearrange it again. I would get A0, you can take it outside, times the summation of x to the power of 2n, right? Divided by 2n factorial, where n is starting from 0 to infinity. You can, if you put n is equal to 0, n should be equal to 0. Okay, if you put n is equal to 0, you would get 1, right? If you put n is equal to 2, you would get this term, x to the power 2 divided by 2 factorial. If you put n equal to 2, you would get x to the power 4 divided by 4 factorial. You see? Okay. Now for the second term, you should get x to the power of 2n plus 1, right? If n is equal to 0, you get x to the power 1. If n equal to 1, you get x to the power 3. If n is equal to 2, you get x to the power 5. Okay. Divided by 2n plus 1 factorial. If n is equal to 0, you get 1 factorial, which is equal to 1. If you put n is equal to 1, you get 3 factorial. If you put n is equal to 2, you get 5 factorial. Okay. Now, if you remember that the first page that I showed you, you would notice that this one is equal to cos hyperbolic x. It's a function of cos hyperbolic x. And this one is the sine hyperbolic x, right? So the answer would be A0 cos hyperbolic x and sine hyperbolic, and A1 times sine hyperbolic x. But the solution that you get from your differential equation, from your characteristic equation, is in the terms of exponential of minus x and exponential of x. I tell you that cos hyperbolic x is equal to exponential x minus exponential or plus exponential of minus x divided by 2, and sine hyperbolic x is equal to exponential of x minus exponential of minus x divided by 2. From that, if you do rearrange this, you would get y as a function of exponential 2. I can do it for you. In that case, I would get y is equal to A0 times right, which is Would it be the same answer? Yes, it is. So you can use either technique to find the solution of this.